안녕하십니까? 컴퓨터 네트워크 5분 세션을 시작해 보겠습니다. I hope my pronunciation was correct. Alright, today's session will be about understanding UDP sockets, and before starting to talk about UDP sockets, I want to show you a small interesting statistic that I found on YouTube. The sessions that I have been uploading were watched just for 15 minutes without subtitles, and the people that have switched on the subtitles, they watched the complete video. That means probably it's my mistake, my big mistake, that I was speaking very fast. And please, from this point, if you have any suggestion about improving the videos, please send me an email or you can make a comment. Because it is actually very important to get to understand the details of the lab course, and as the content that I provide, some of the parts could be in your exam, or if we might have some quizzes. I am not sure about that, so please try to pay attention to the details, and from now on I will be trying to speak slower. At least not as fast as in the previous sessions. And also one more question that I have been asked from students was if we would have to do the same installations on Mac, for example, CyGWin terminal installation on the Windows, as in Linux, if we have to do the same installations on Linux and Macintosh as well, like MacBooks. No, actually you don't have to, because we were installing CyGWin terminal because a library that we were using for sockets is not available on Windows environment, and it is available in Mac and Linux environments by default. So you can just open your simple terminal and compile the source files that I provide just from here. Just type on gcc-o your executable and then your file name. Alright, I hope I answered the question. I will start the UDP sockets. Characteristics of UDP sockets. The UDP socket is also the part of TCP/IP protocol family, which is the Internet protocol stack. It is located on the transport layer that is located below the application layer. It provides a communication protocol to the applications, to network-based applications, and it is referred to as connectionless, and that's called and the IP layer provides best effort network, so it's providing an application layer a connectionless exchanging point. Alright, so the segmentation, by which I mean how the packets, how the message that you're trying to send to another host is divided into segments. In UDP, it's actually your message is not split into segments like in TCP. TCP has its internal segmentation. When you try to send a message to another host using TCP, your packet, your message is actually split into segments. And in UDP, it is not split into segments, and it is transferred as a whole at once. And the TCP contains error detection and corrections, but the UDP does not actually have error correction. It has a error detection using checksum, but it does not correct the packets. It just ignores the packets that have a problem. All right. So it is a connectionless protocol. It is not based on a connection, which means it does not instantiate a socket. It does not instantiate a connection when you create a socket like in TCP. And that means there is no sequence acknowledgement or flag fields in the packet. It just has the packet data. And also it does not have any congestion control. It just uses simple packet delivery methods. And it is actually commonly, UDP is commonly used for broadcasts when you try to send a message to all available network nodes in your network, and uses ports just like TCP. And there are some specific UDP ports that are taken, which are SNMP protocols, for example, which is 161, or TFTP in UDP, for example, 69. All right, we will just go into the UDP implementation, how it looks like and how it works. So again, TCP's concept of connection disappears when you're working with UDP. So if you're switching from TCP to UDP, which is what we are doing right now, we will be forgetting about a connection, everything about connection. There will be no connection. And UDP, because UDP is not connection oriented, it's connectionless. Oh, it is difficult to speak slowly. It's very difficult to speak slowly. Therefore, we just create a single socket on server side and another socket on the client side, and then we can just move on to sending and receiving step. But first, on the server side, we have to bind that socket still. We have to bind it to an address. But the rest is just much more simpler than how TCP worked. Like TCP had a lot of steps, for example, binding, listening, accepting, etc. But UDP is very simple. So you just create one socket on any host. So now we can just forget about the UDP server and client, like client and server communication. There will be just this simple socket that can communicate with any host. So there will be just one host talking to another host, and that will be applicable to this host talking to this host as well. And that's why one socket can communicate with any other host, All right, the functions that we will be using for UDP sockets, for exchanging messages using UDP sockets, are called send to, for transferring a message to another host, and receive from, to receive a message from another host that just sent us a message using UDP send to function. Send to, we are going to be using send to because we don't have a concept of connection in UDP. And before we were using write function call in TCP because the socket file descriptor was connected to another computer, another host, before making a write function call. That is why we were not using any kind of send or send to function call, but we were writing bytes to a socket file descriptor. But now we have to specify to which address we will be sending this packet, this message to. And we have to specify which address we are going to be reading a message from. So that's why we don't have a concept of connection anymore. In UDP, we'll have to specify the destination address, and each time we call send to method, the function, the message will be sent as a whole to another host, unlike in TCP's write function. All right, so the arguments are the socket file, which is a file descriptor of the socket, and the buffer, which contains the message, and n bytes means the length of this message, and the flags and the address to which we want to send to, so on and so forth. Okay, receive from. One socket can receive data from multiple hosts, so we have to just create one socket where we will be specifying socket dgram instead of socket stream that was for TCP, and we have that socket file descriptor, and we will provide that socket file descriptor to receive from, and it can accept a message from any address that we specify here, just using that simple one socket file descriptor. Therefore, we can say that UDP socket can accept data, it can receive data from multiple hosts using just simple one socket file descriptor. Therefore, we'll have to load source address that has sent us the data. All right. If you remember how echo server and client worked, I have provided a source code that is based on UDP, that is doing the same functionality as TCP echo server and client, where a client was writing a message to the server by getting the message from user input, and sending it to the server and receiving the same message back from the server. So here the UDP is doing the same thing. We are first creating a socket up above, it's not here, and we are binding that server socket to an address, after which we are not doing the steps like in TCP, like listening and accepting. Instead, we are directly moving on to receiving a message from a client address. So the UDP-based echo server is receiving the message that a client has sent and sending back the same message to the same client at the same time. So we have an infinite loop that's just bouncing the message back, that's making the messages bounce back to the source clients, source hosts. And the UDP echo client is sending the message like I just told before. It's getting the input from a command line and sending the message to the server and receiving the message again. So this makes up a whole UDP-based echo client and server. And the TCP had a boundary that was due to an internal buffer size. That's why it was split into several segments. And UDP does not actually divide your data into segments. It just sends the message as a whole at once. What that means is when you make a send to function call, your whole message will be sent at once. And this is actually a very good example of how we can get to understand how the UDP works, how differently it works than TCP. For example, here we are in the, let's say, host 1, we are making 3 consecutive send to function calls. And what that means is it will directly send the complete message at once. And if you notice, at the first time when we are making a send to function call, we are providing MSG1 is an argument, and then we are sending MSG2 and then MSG3, which have different values, which have different messages. The first can be hello world, and the second message can be this is the second message, and the third can be just something else. And what the receiving host does is, it does not matter if you are receiving the content that another host has sent you with delay between each time you call receive from, or without delay. Each time you call receive from, you will get the first message, the whole message that was sent the first time when the send to function call was called. That means if the content of MSG1 was hello world blah 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 blah, then the first time this for loop iterates, you will be getting that first message, hello world blah blah blah, at once. And the next time it iterates, which it runs after 5 seconds, and by that time actually we have all these two MSG2 and MSG3 messages also delivered to this host. The receive from function will still give you the next message that was sent after this MSG1, that's MSG2. So let's say the content of the MSG1 is MSG1 and the content of MSG2 is MSG2, and so on and so forth. Then the first time this for loop iterates, the first receive from will give you back MSG1 only. It will not give you MSG1, MSG2, MSG3 all concatenated into one string. It will give you only MSG1. And then after sleeping for 5 seconds, even though both the left two packets are already delivered to this host, it will still differentiate the two messages. It will first give you MSG2, and then it will wait for 5 more seconds, and then it will show you the MSG3. All right. So now we can move on to the source codes, and we can try to understand how the echo clients and echo servers work. And I have 2 more source files that are very interesting about UDP. And I created one network-based program where we can make a remote operations, remote arithmetic operations using the computation, so to say. We can calculate an arithmetic equation using a remote host. We will be sending, for example, 1 plus 2 plus 3 plus 4, and the result will be calculated in a remote host. So this is one also very interesting network-based program. I will explain with details a little bit later at the end of this session. And the first source code that we will be taking a look at is TCP-based echo client and echo server. So first I will show you how echo client and echo server works, and then I will go and show you the difference between TCP's echo client server and UDP's echo client server. All right, so like I told you a little bit earlier, UDP does not have a server and client, it just has hosts. But here we are saying client and server because we are using the UDP in an echo client, echo server way of implementation, where we have to call one host as client and one host as a server, because server will be sending back the messages, and because the functionalities are different. That's why. Okay, so let's first take a look at the TCP echo client and TCP echo server. All right. Oops, we have a lot of files here. So the example that I wanted to show is the echo client and echo server.c files. Let's copy them and paste in our cygwin folder again. Oh. Okay. Let's paste it here, and let's open the 2 source files using Notepad++. I sound weird to myself when I speak slower. Okay. So in the echo server part, the functionality of the echo server part was to send back the messages that it would be receiving from TCP clients. And I want to remind you one more time that I'm showing the TCP example of the echo client and echo server. Even though today's sessions are about UDP, I will be starting with TCP so that you could understand the UDP better. So from the beginning, we actually I believe we understand the meanings of the first lines from the previous session. And if you do not understand, please take a look at the previous lab session where I have explained the meanings of these variables. So we need, in the TCP, we need the 2-socket file descriptor for a server socket, to open a server socket that accepts client sockets, and we have to have one more client socket so that this echo client could connect to the server. And we are creating that server socket here, and make a note that this this value is still sock stream. That means it's still TCP. And we are listening to any client's connection from any interface on our computer, and we are binding that server socket to our server address. And then we are listening to client connections with a backlog of 5. So there will be a queue with length of 5, and here what we are doing is we are accepting 5 clients in an iterative approach. So we are dealing with one client at a time, and when that client is closed, when that client just sends one message and receives back that message, it closes that client socket and moves on to the next client. So after accepting one client, we will have that socket file descriptor here that deals with a client, and then we have a while loop that reads the message that a client has sent to this message buffer that was created above here, and that contains we have created a big buffer so that we don't have to create long for loop, while loop stuff right here to keep track of the message length. So we just made a buffer size very big, and then we are writing back that message that we have just received after this line of code by using the write function call, because it is a TCP socket. So we are writing back to the same socket file descriptor, after which we are closing that client socket and moving on to the next client. So now we can move on and play with the client source file. Here it does almost the same steps as the TCP server by creating variables and buffers. And the one thing that it's doing differently than the TCP server is it is connecting to the TCP server. If you have watched the previous lab sessions, then you must understand why we're making a connect function call here. And then we are opening a while loop that sends. It is actually not logically correct, but let's say, okay, let's just skip this part. We are getting an input message from a console, from a user, and then whenever the client enters queue, it's just breaking out from this while loop. We could have just sent one message, instead we're sending multiple from one client. And then after getting a message from a console, we are sending that message using a write function call to the socket that we have created right here and connected right here. So we are sending the message to the server on this line, and then we are reading the message that the TCP echo server has sent us back, and we are printing out that message at this point. Actually, this line is an important line. Why? Because when we receive a message through a network, our buffer could contain a lot of trash values inside it. For example, the message might have this kind of content from before, and maybe this time when we called read, the message that we have received had a length of 2, for example, let's say AB. The message was AB, but we have this length of a bunch of junk in our message buffer, and when we make a message strlen is equal to 0, that means we are stopping at this point, because this str length is pointing to this point, and it will be just a 0 value right here, and that means it will be the end of string, and when we print that message we will be only seeing AB as an output instead of seeing all this junk from the previous message exchanges. Okay. And after this, we are printing out the message. And then when the client decides to quit, we are closing that client socket. Alright, so now we can close this TCP echo client and server source code and compile these two files and run them. Okay, let's open up two terminals. Okay, how was I? I don't like Windows. I wanted to just increase the size here. How come it's not? Okay, I could not increase the font size, but please try to see what I'm writing here because I could not change the source. Okay, options. Alright, okay, so I could not increase the font size, even though it's small. Please try to see it yourself. Okay, gcc-o echo server, and let's say the echo server.c file. So up above we are going to be running the server, and down below we're going to be running the client. gcc-o echo client echo client.c. And let's run the server first and specify the port right here. Okay, we have to specify the port number here because we are accepting the server's port from the arguments that are being specified from the command line. That's why we have to specify the port from here. It's not server, it's echo. It's echo server, it's my mistake. Okay, so alright. So now we are running the echo server executable, and now from this console we have to run the echo client example executable, and we have to connect to the local host with a port of 4444. So it has just connected to this server. It has connected for the first time. That means the server is working in an iterative approach, and it's ready to receive our message and send it back to the client. So let's just enter, for example, first message. So what it just did was the echo client has just sent this first message to the TCP server, and TCP server automatically sent back that message to the same client. And that's why we have received the message from server saying first message. Now we can just click Q to close this socket, and now this console will be ready for the second client to connect to. Let's run the same thing the second time and say ASD or anything you want. So it just run for the second time. Let's quit it, and let's connect as a third client. So it just accepted the third client, and let's say whatever we want, and stop that too, and repeat the step until it reaches the fifth client, because we are accepting 5 clients. So this is the last client that the echo server is going to be accepting, after which, with an iterative approach, and it is going to terminate. Let's go ahead and make sure that the server terminates properly. So now we can see that the echo server worked in an iterative approach with 5 clients and just terminated successfully. So this was the TCP echo server and client example, and now we can go ahead and play with UDP echo client and UDP echo server, and that is written in uecho client.c file and uecho server.c files. Let's copy those two source files. Why can't I just select the two source files? Okay, not sure why I can't. I will just drag and drop to the cygwin folder from here. Okay, C drive. Oh, I think I have direct access. Okay, I have direct access. So I will copy this one into this folder, uecho client and uecho server file as well. And now let's open the two source files and try to understand how UDP does the same thing that TCP was doing. So this uecho underscore server.c file has the echo server that sends back the messages that uecho client sends to the server. It just keeps sending back the same messages. The creation steps are exactly matching with the TCP server, but I wouldn't say exactly matching because we only have one socket here. We don't have the client socket like in the TCP echo server, because here was client socket as well. And now instead of that we have only one socket here. And that socket is being created right here, and I want to make a note here that the parameter is not socket stream anymore. Before it was socket stream, but now it is socket dgram. That means we are going to be sending datagrams, not streams. Datagram is a UDP message. So I would say UDP, you can understand like a packet, let's say a packet. So UDP's packets are datagrams. And after creating a UDP socket, we are checking if we have the socket created. And the same way as we were binding that socket to an address in TCP, we are binding the same way in UDP as well, by saying inner any and binding that socket to this address. It's exactly matching. And skipping the two function calls in TCP, like listening and accepting, we are just jumping through receive from function call right here. So after step of binding, we are moving on to receiving and sending message. So the uecho server file is going to be making these two function calls and simply iterating infinitely. That means it is not going to be working 5 times like in TCP, it is going to be working infinitely. Okay, because there is no connection, there is no such sense of connection, we don't have to do the iterative approach because it can work with any client at any point. And I will open 2 command lines and show you that it is doable, that 2 hosts, 2 client hosts talking with the one server uecho server host at the same time. But before, I want to show one more thing about TCP in order to compare it with the UDP. I want to copy the TCP source files again one more time. The echo client and echo server, I want to show one more thing so that we would have something to compare to with UDP. Let's open up one more console instead of opening just 2 consoles for server and client. Here we will be running the TCP server, and here we will have TCP client 1, and let's say this will have TCP client 2. Let's compile the TCP echo server file right here. gcc-o, let's say server and echo server, and here gcc-o client echo client.c file, and let's run the first client on this console 127.0.0.1.4444 and copy this command and paste it on this console. That will be our second client, and let's connect the first client by clicking enter, and then let's click enter on the left console also. So it has just said it's connected, but the difference is actually the first client can send a message and receive it back, but the first client cannot actually send a message because when you click it, the server will not be responding. So for this client to receive that message back from this client, this client has to quit. And then once this client quits, then the server can work with the second client. So therefore, the TCP iterative approach has a problem with working with multiple clients at the same time. It cannot exchange messages with multiple clients. Okay. So now that we have seen how the TCP echo client iterative approach works, let's see the same thing with UDP. Sorry for abruptly jumping to the TCP example again. And now, because I showed that in order to show you the one very visible difference between UDP and TCP. And the difference between UDP and TCP from that point of view, from iterative approach point of view, is that if we compile the UDP source files, just like we've done TCP, and run multiple clients at the same time, then here is what will happen. gcc-o server u echo server.c file, gcc-o client u echo client.c file. Here's, you will see what will happen. And let's copy and paste this command to the next console as well. Oops, client 127.0.0.1. So the server is already running. What we will be doing is we will connect the first client here, and then we will connect the second client as well. Okay, I forgot the port. So the first client, both clients are now connected to the server. It's saying that it's connected. Actually, it's not connected. It doesn't have a connection, but we have created two sockets on these two hosts. And because we don't have such a thing as connection, we don't have that iterative approach issue anymore. And now if we send a message on the first, this host, then we'll receive the message like all fine. And then if we do the same thing in this client, we will be also receiving the message. And that is happening because the UDP server, which is just simply a UDP host, work with any host at any point. And it does not have to be connected to a specific host, specific computer, specific client, like TCP was required. The TCP protocol is supposed to do. Like TCP server was connected. This TCP, if let's say if this console was a TCP server, and this was the first client that has connected to the server, then it had actually a real connection between those two hosts, and therefore the third party, the second client, could not interrupt the connection, could not go in and just start sending and receiving messages as well. But we don't have that notion in UDP. They're just hosts. All of them are just hosts. They can interact with each other anytime. And they're just using one socket to talk to any host. That's why we have this message exchanging working like anytime on any client. So let's just terminate it, and we don't have any response on the server side because it does not know if any clients have disconnected because they were not connected, because they don't have such a thing as connection. Okay, now let's take a look at the client part as well, as the server was just receiving a message and sending it back. The client is also doing just very simple steps like the server, because they're doing actually exactly the same thing. Like they don't have accept and listen steps, so that's why the two hosts make the same function calls. But instead, but the small difference is even though the UDP server makes a bind function call, the UEcho client doesn't have to. So we just create a socket here, and then we jump on to sending step. So if you take a look, we're just specifying the address of the host that we want to connect to, and we are just moving to sending message step. We are receiving the message from a console, like I've shown a little bit earlier, and we are sending that message and receiving back from the UDP server, and then printing out that message. Alright, now that we've seen the UDP Echo client and server examples, we can go ahead to the next example, which is the operations OP client and OP server. It's actually an interesting example because it is actually a network-based, really network-based application that will provide you a functionality like remote data processing, for example. It is a small example of remote data processing where a client will be making use of the server. Actually, it's a TCP server. It will be making use of this TCP server to make like calculations, like simple arithmetic calculations. It doesn't have to calculate itself. It can be a good like starting example, like preliminary example for big remote data processing, like sensor data processing, where your phone just sends the sensor data from using a socket to the server, and server processes that data and returns a result. This is just one small example that can be compared to that kind of big network program. So this example, I will just go ahead and first show you how it works from command line. For that, what we will be doing is we will be compiling the TCP OP server and OP clients. For that, we'll be doing gcc-o server and op server.c file, and gcc-o client op.client.c file on this side. So let's run the server on the left console on the port of 4444 and connect to that server with the localhost IP address and with the 4444 port number. So now the client is connected to the server. I will show you how this works. For example, if you want to calculate this this kind of value remotely, for example, 1 plus 2 plus 3 plus 4, if you want to calculate the value of this equation on the server side by making a just by sending a packet, a message that contains these bytes, then you will just say, I want to send you 4 operands, because there are 4 operands, which is 1, 2, 3, 4. I will be sending 4 values, and then we will enter 1, 2, 3, 4 consecutively, and then we will say, I want to add them all. We will be sending the operator. So let's say I want to plus out the 1 plus 2 plus 3 and 4. So I want to send 4 operands, 1, 2, 3, 4, and we will get the operator by saying plus. So now we have the result, which is 10. It seems very simple, but the interesting part is that this application is network-based. It's not calculating on its own. The client is not calculating this on its own. It's sending that operation to the server, and server is making the processing and returning back the value of 10. So we can check that one using simply connecting that client again and just stopping that server on this point, and just say enter the same thing again, 1, 2, 3, 4, and making plus, and the operation is giving us a wrong value because it's just a trash value. It could not send a message, it could not receive it. It's just exception because the server was not replying. If you turn on the server again and run the client one more time and say the same thing, 1, 2, 3, 4, and say plus again, you will have 10 because the server is running. So the calculation is being made on the server part. So it's interesting, right? Let's just open up the source files and see actually how this is working. This is magic. It's not magic, it's very simple. So what the server part is doing, okay, now I don't want to start from the server part. Now I want to start from the OP client part instead of starting from server part. What the client part is doing is actually, I will skip the socket creation and connection steps. I will just move on to the network app operation core, the message exchanging part. We are getting the number of operands as a first step. We are getting the operand count to this variable. So we are getting that decimal to this integer, and we are loading the value of that integer, which will be, for example, 4 or 5, and we are storing it as the first byte inside our buffer. So right now, the bytes inside this OP MSG are as follows. OP MSG contains this byte as the first value, not 0, I would say 4, because we have specified 4 right here. And then using a for loop, we are getting values of each operand after this. We are just looping through the values this many times, and then we are getting the decimals each time. The first time this for loop runs, the value of the OP MSG will be, so after doing the scanf, the value of the OP MSG will be 4 and then 1. The 4 says number of operands, and 1 means the value, the first number that we have just received. And then the next time this for loop iterates, the value will be 2. The next time it iterates, it will be 3. The next time it will be 4. And then now we have all 4 operands. And then we are getting the operator the last time. And once we have that operator, after getting that operator using a character which is 1 byte, we are storing it to the last as a last element inside this buffer. So after this step, what we have is the same values as here, but with a plus character at the end. So now what server can do is, oh, there are 4 elements inside the there are 4 operands inside this message. So, and then server reads 4 elements consecutively, 1, 2, 3, 4, and then it gets the operand operator, and then it makes this operation on all those 4 values. And then what this OP client is doing is, after sending the message, it's reading back the result and storing it inside this result variable that was not initialized from the beginning. It was just empty. It was just 0. And then we are reading back the result, and we are printing out the operation result that we have just received from the server. So now the interesting part is, how is actually the server calculating these values? Now what we will be doing is, we'll open up the OP server file and run it to make sure that it's working correctly. Let me just make sure to delete the lines of code that I've just made. Okay, I've just cleared out. And on the OP server part, I will again skip the initialization steps. It's just simple TCP application. Let's just skip this part, like binding, listening. So this for loop is accepting 5 clients again, and each time it's accepting 1 client, it's reading a 1 byte operand count, which was the first message, the first byte of a message. For example, here, if the incoming message to our server from client was 4, 1, 2, 3, 4, and plus, we are just saying I want to read just 1 byte and store it inside this integer. That means we are just reading 1 byte, which is the first byte, and then we are running while loop. We can just run for loop as well. It's just up to us. And we are reading those values and storing them like this. We are reading the values, the next values, and storing them inside here. And then once we have all these values stored inside our operand info, which is also just a buffer, we are just storing those values that we are receiving from the client. Once they are collected from the client, we are we are making a function call to this calculate function and providing the OP info as an integer pointer. That means it can be considered, the byte array can be considered, which is just array of each bytes, can be simply considered as a byte of the array of integers. So that's how we are just casting it into an array of integers as here. And then we are saying the last element of this OP info is what was the last element? The last element was actually, the last element is actually the operator. So now we are giving those parameters to the calculate function that we created by custom, that we specified up above, that we have defined up above and implemented down below. So if so what it's doing is it's accepting the number of operands and the operands themselves, and as an array of integers, like I told you a little bit earlier, that we're casting it to an integer pointer. And as the third parameter, we are accepting the operator, and we are simply making a switch case with that operator and checking if it's plus or minus or multiplication, and we're just skipping the division part. We can also make as division, like if you want to do, or we can make a modulus. It's totally up to you. It's just an example of a network application. That's why we're just making just these three. And if it's plus, which was the case that I showed you a little bit earlier, that I've just run, where the data was 4, 1, 2, 3, 4, and plus. So here we are checking if this value is plus. That means we will be ending up here, and then we are running this for loop on each operand here, and we are adding each operand to our result, which is at the beginning the value of the first value inside this operand array. And just skipping the first operand, we're starting from the index number 1. That means if the value that the values that we have here were just let's say 1, and the first element that we specified was, for example, 2, then right away at this point the value would be 2. The result would be 2. And because the number of operands is just 1, it would be 1. And then this for loop would not work. That means the result would be simply 2. That's how it works. This logic works, and it's not very difficult. It's very simple, actually. I hope you understood how it works. And then it's returning the result. And after this calculate step, we are writing back the result of this operation to the client. So the result is actually an integer, like you can see here. It's an integer, and it contains 4 bytes. So we are sending those 4 bytes like by casting the address of that integer to a character pointer. That means we are considering this integer as a buffer of size of 4, and the size of result returns us 4 because it's an integer and it says 4 bytes. So the client is going to be receiving an array of size 4, a value of size 4, a value of size of 4 bytes. Now it was correct. And after this, the OP server is just closing the socket. Now again, if we try to run it and see how it works, then we would make sure we will be completely clear with how the OP server and client is working. So on the left side, I will be running the server 4444, and on the right side I will be running the client 127.0.0.1.4.4.4.4. Once we're connected, we can specify as many operands as we want. Let's say 5 elements, 5 multiplications of value of 2. Let's say that will be 32 to the power 5. I believe, if I'm not mistaken. Okay, I have given 5 values of 2, and I'm specifying multiplication. Now what we have is 32 that was calculated on the server side. And if you close it again and connect to it and say, oops, we cannot even connect to, I should not have disconnected. If we run it again and connect here and then close the TCP server, oops, and here say 5 values of 2, 2, 2, 2, 2, and then the multiplication operator, the result will be invalid because the server is not working. Alright, I hope it wasn't very complex to understand. If it was, please let me know by comments or by an email. I can explain you a little bit earlier on the office hours. If you can visit my office during office hours. But I don't recommend to due to the situation with the virus. Alright, so the last step is the bound host 1 and host 2 examples. It's a little extra example. It's not last, actually, there's one more, but like one before the last one. I want to show this one as well. Let's go ahead and copy it inside the Kevin folder and compile and run to see what it's doing. gcc-o host 1. Oops, I don't remember the name of the file. Okay, bound host 1. And the second file will be gcc-o host 2 bound host 2. So what this bound host 1 and bound host 2 are doing is host 1 is accepting all the messages that host 2 is sending, but by the way, it's using UDP socket, but it's not simply getting all the packets, all the messages at once. This host is going to be sending 3 messages instantly, one after another. It will just send 3 messages when we run it, and the host on the left side is going to be receiving those messages from this host with a 5-second delay. What it does is it first receives the first message, and then after 5 seconds it receives the second message, and then it receives the last message, the third message. And first let's run it and see it ourselves, and then I will explain the source code one more time. It's actually this exactly same source code that I've shown in the slides on this page with a delay of 5 seconds. Let's run the host 1 first. Oops, with the port. So the host 1 is already running. It's waiting for the messages that must come from the host 2. Let's run the host 2, 127.0.0.1 to the port number of this. So it's just received the first message, and then after 5 seconds it receives the second, and then it waits for 5 seconds more, and then it receives the third message. And now you might be wondering, what is the reason that we have just seen this? Of course it works, but the nuance is that even though all the messages were already transferred from the host number 2, one after another without waiting, it's not waiting for 5 seconds to send to the host 1, it's just directly sending all messages and just stopping, it's just exiting. The host 2 is already dead, so if you notice it, I will run it one more time so that you can see it. So the host 1 is running, the host 2 is running, but it is just terminated. It's not running anymore. It's not sending these messages, but it's receiving the message after 5 seconds. What that means is the host number 1 shows us how UDP, how socket datagram receives and sends one message as a whole at a time. So that's what we should get. So if you make a receive function call, even though all the bytes have been transferred, all the bytes of message 1, message 2, message 3 have been transferred to host 1, each time you call receive from, you will receive the result of a single send to function. But in TCP, it's not like this. But in TCP, you will receive all messages one after another. When you call this read function instead of receive from using TCP. In TCP, you will get whatever data that is available on the stream, on the socket, through the socket. But in UDP, you will receive only one function call at a time. So that's the thing that you should understand, and if you don't understand, please make sure to re-watch this video, or if it's very difficult, then you can visit me during office hours. And then it's printing out the message, as we saw in the example, in the command line, in the cygmin. All right. So now we have, now that we have covered these source files, the last interesting source file is this con client, which is a very interesting point, which is a very interesting source file. Why? Because UDP has a nuance. A UDP, like technically, from a programming perspective, from a computer networking perspective, UDP has a connected there is a connected version of UDP socket as well. So what that means is you can create a UDP socket and make a connect function call. So what will change when you make a socket connected, make a UDP socket connected? The three things will change in UDP socket when you try to connect it to an IP address. You can no longer specify the destination IP address and port number as an output operation when you call send to. So you will not be calling send to anymore. You will be using write instead, or just send, because the target has already been defined before this. So that's what changed. The target host will have been already defined, so you cannot be working with multiple hosts at a time. You will be just using communicating with one. So technically, a connected UDP socket exchanges datagram with only one IP address, because it's possible to connect to a multicast or broadcast address. So you can just connect to a broadcast and you will be receiving a message from any host that is broadcasting any message. Actually, this is the specific reason why the connected UDP socket was created, to listen to multicast and broadcast addresses. So we just use read and receive or receive message instead of receive from. We don't specify where we are receiving the message from. And the asynchronous errors are returned to the process for returned UDP sockets. This issue is only with the UDP sockets, as unconnected UDP sockets do not experience asynchronous errors. Alright, I hope you guys had a nice time. The last thing that I want to say is 안녕히 계세요.